Okay, number 14 is a cube root. And the cube root problem is very similar to the square root problem. It's depending on another pattern. And the pattern it's depending on is this pattern right over here. But the first thing I'd recommend you do is to write it in the proper order. All right, so I'm going to say proper order. If you look at it, I'm going to say descending powers of x. All right, so descending power of x's. I'm sure you see what I'm doing over here. All right, and then if you look at the other side, it's got ascending powers. You know, if I look from the right to left, it's ascending, right, the y's, right? So descending, ascending, okay? So what I would do is make an assumption about this. And I want to point out what I mean about assumptions about this, that it's a perfect cube. And if that's the case, I want to point out, whoops, sorry about that. If that were the case, I want to point out that you'd get something in the beginning. And the beginning has something to do with this. And again, I'm making an assumption it's a perfect cube. Now, what would you get in the beginning? And it's usually, it's like trial and error. That looks pretty easy, just 3x squared. The reason being 3x squared when cubed is 27x6. And the trailing part also looks fairly easy to do. What's it going to be? Minus 4y squared. All right? The problem for me, though, is always the middle part. And certainly if I were looking at it, I would say that there has to be something in the middle. So looking at it, I don't know what it is. So I'm just going to say plus a. Right now, it's descending power of x. So I'd say x. So x squared, x, no x. If I look at the y's, it's y squared, y. So my problem now boils down to this, with the assumption that when this thing is cubed, it would equal this. The trouble now is the expansion. So, you know, what I would recommend you do, I'm not going to do it because I did the squares already, I would expand it. Right? And when you expand it, what I do is I do what's known as equate coefficients. And we did that for the square problems. So it's really the same technique. And if you do that, you're going to find out that a is equal to minus 1, right? Now, granted, you know me, in the prior problems, I kept checking to make sure everything worked out fine, but it's really not that bad to do. Now, certainly, some people are much better at this than others. They do this in their head. I find that to be very, very skillful. People can do that. Now, certainly, the assumptions being made, perfect cube, sorry about that. The assumptions being made, perfect cube, it's the middle guy. That's tough to figure out. But again, I'm seeing a pattern, expansion, equate coefficients, you'll eventually get the a to b minus 1. All right? Then what do? Take the cube root of it. Fairly easy to do. You'll get exactly what's specified over here, 3x squared. Again, if the a is minus 1, you get minus xy minus 4y squared. Relatively simple. Thank you.